Welcome to another part of the ISM Exercise Set Microeconomics, this time with a unit on Polypolies. Let's have a look at the exercise. Here we have a company produces printers. These printers can be sold on the market for a price of 392 euros per piece. The company faces the following internal cost function. And we have here 2x squared plus 72x plus 98. Our tasks: determine the profit maximizing output of the company, calculate the profit of the company, and how many units will each company offer on the market in the long run, and what price will the market settle down to. And finally, how many companies will be active in the market in the long run if the total market demand results from the following demand function. And we have x being minus 3p plus 370. Okay, let's work our way through this step by step. Before we can do this, however, let's first recapture the cost and use this to get our marginal cost, because that's one of the first steps we need. Marginal cost, that's simply the first derivative of the cost function. So here we have 2 times 2x plus 72, and the 98, that's omitted because we don't have an x there. So our marginal costs are in total 4x plus 72. In addition to the marginal costs, we also need the average costs later on. The average cost, that's just dividing the cost function by x. So here we have 2x squared by x is 2x, 72x divided by x is 72, and 98 by x is 98 divided by x. Then we are more or less ready to go. So we can start with the first part, determine the profit maximizing output. And for this, we are equalizing the marginal cost function and the price from the exercise. Whenever we hear something or whenever price is given and there's nothing in the exercise text about long run, this usually means take the price, equalize this with marginal costs. So here we have 392 equal to 4x plus 72. Then we just solve this for x, so we go minus 72 and divided by 4. So it's 320 divided by 4 is 80. So our profit maximizing output of a company is 80 at a price of 392. Well, we have the price, we have the quantity, so we can also calculate the profit of a company in this situation. For this, we remind ourselves the definition for profit, that's revenues minus costs, and revenues is quantity times price. So here we go 392 times 80 minus, and then we insert the quantity x into the cost function. So here we have 80 times 392, then minus 2 times 80 squared, that's a 6,400, plus 72 times x, so 80, plus 98, giving us a total profit of 12,702. That's already part B. So for part C, we're asked about the long-term situation, a long-term equilibrium. Well, we see that there was a profit to be made. So profit in part B was positive. So meaning the profit will decrease. The prices will drop. This we can keep in mind to compare this later on. However, whenever you read something with long-term equilibrium, long-term solution, this always results in you going on and equalizing average and marginal costs. So that's what we're going to do here as well. So we have average cost 2x plus 72 plus 98 by x equal to 4x plus 72. Well, we can solve this for x as well. So first we bring all the x's on one side. So we go minus 2x minus 72. Then we get 98 by x equals to 2. So we multiply this with x, giving us 98 equal to 2x squared. If we divide this as well by 2, we get 49, or x squared being equal to 49. And here we have a solution x being 7. Well, theoretically speaking, we would have the solution x being minus 7 as well. But from an economic point of view, this does not make sense. So we are only stuck with one solution, that's x being equal to 7. And this 7 we then can insert either in the average cost or the marginal cost. As with most of the parts, it's usually easier to go with the marginal cost. So we insert the 7 into the marginal cost and get here 4 times 7 plus 72. So we have a price in a Polypoly of 100. And well, if we take a critical look and compare this to the solution before, then we see, well, before we had a price of 392, now we have a price of 100. So yeah, this makes sense. So whenever we have a profit in part B, this will be a sure indicator that the price in a part C in the long term will be smaller than it has been before. If the profit would have been negative, so we would have a loss, then the price would be higher in the long-term equilibrium. Okay, so much for part C and the comments on part C. We are still stuck with one final part, and that's on the total market demand, or the total number of companies which will establish themselves in the long run. For this, as we see here, we start with the total market demand. So at a price of 100, how much goods are bought in total by the whole population? And for this, we just insert the price we determined in C into the demand function. So demand at a price of 100. This means we insert this here. So we have a quantity of 370 minus 3 times 100. So a quantity of 70. Okay, that's the total market demand. And each company has a profit maximizing output of 7. That was part C. So if we have a total demand of 70, each company produces 7. This means in total we need 70 divided by 7 companies. So the number of companies is 10. And well, that's all there is to this exercise. So I hope you enjoyed listening to it. And if you want to see more exercises, feel free to visit the rest of the exercise set or have a look in the corresponding playlist. I'll say goodbye and see you next time.